and let's go ahead and get started. I'm Andy Millin, and that is my airplane. It's 114 Mike Victor. I got lucky to have somebody take that shot for me when we were at Oshkosh. This webinar is for your information and consideration. I really like working on my Velocity. I hope you like working on yours, but I'm not your mechanic. So you have to decide what's best for your airplane and how you're going to maintain it. I do not work for Velocity. I don't sell parts for Velocity. I also do not work for or sell parts for Scott's Performance and their damper products. I'll start off with this. Take a look at these Velocities. And other than being fixed gear, can you tell me what they have in common? I know I've got you muted, but tell you what, here's some more. What do they all have in common? And I'll go ahead and jump to it. They don't have any wheel pant on the nose. And the reason they don't have a wheel pant on the nose is because they've all probably thrown the wheel pant off the nose via shimmy at least once. The first time I'd heard about this was with a gentleman named Quint Daniels. He's close by. I think he built kit number 12 from Danny Mayer. And I asked him why he didn't have a wheel pant on his, and Quint said he tried and had thrown it off twice, and once it went through the prop. So he was done trying to run with a wheel pan on there. He said it just started shimmying too badly. I was nearing my completion myself when this shimmy idea was brought up to me. I actually didn't have any idea that it could be a problem. I decided to go to Dwayne Swing one year at AirVenture and just ask him, is this really an issue? And I walked up, and there's John Abraham and Dwayne Swing, and I'm asking Dwayne, is this an issue? And they both go, oh yeah, it's an issue. Fixed gears especially, but retractables also have shimmy issues from time to time. And they did agree that if you put a wheel pant on the fixed gear, the increased mass will greatly increase the chance of it throwing it right off the airplane. Dwayne then went on, because I'm asking, well, what have you come up with to try to fix this? And Dwayne said he'd made a gear fork out of carbon fiber with some type of spring mechanism and some kind of boot on it that he was going to put on the airplane. And John Abraham looked at me and looked at him and said, I'm never flying an airplane with that thing on there. You're going to get someone killed. To my knowledge, Dwayne never actually got to put that on an airplane. But in all seriousness, I said, well, what are you really doing? And Dwayne looked me in the eye kind of the way that Dwayne does and just said, I've been waiting for a builder to solve this. Oh, please, don't tell me this. I was a little disheartened and frustrated, to be honest. I was not out for the entertainment, and I was definitely not out for an education on this, but like a lot of things with our airplanes, if you're going to get into it, you're going to learn something. So first thing here, I wanted to learn exactly what is shimmy and what are its causes and how does it happen. Shimmy is very simple. It's like gravity. It's like light. It is just a physical phenomenon, and it is a harmonic oscillation like a pendulum. It is not particular to the Velocity. It happens in any airplane that you have a castering or movable nose wheel. That's all the way up from the largest airliner down to the very smallest Cessna 150. Cirrus has it. I have a friend who took me up in his SR-22T, and I said, you ever had a shimmy problem? He says, no, not that I know of. And then I looked at his nose wheel pant, and the bottom of it was badly beaten up and frayed. Like, oh yeah, this thing has had at least one shimmy on it. There's nothing special about it. We're all trying to use a castering nose gear so we can steer the airplane. For our airplane, let's see here. We actually have a number of possibly pendulous actions. If we look at the pivot point here, the easiest analogy would be where the gear fork is turning on the strut, and then the wheel would be able to turn down here. We also have the possibility of the top being the strut, and that's attached into the keel. And the strut could move side to side and also create an oscillation, and that could start a shimmy. Anything that could move in here, these could actually be largely fixed, and you could have the flex in the tire creating the possibility for shimmy. It's a little different for us, I think, because in the Velocity, especially in the XLs, they sit a little bit higher, so that means the strut is a little longer than something like a Cessna or a Cirrus, which that's beefier too because it's right under the engine. It's attached to the engine mount, and their nose strut is usually shorter and stronger. Ours has a little more mechanical advantage, so it can whip the top of the gear strut around a little bit more. But it is simply something that if you leave it alone and leave it at rest, it will stay in the center. If you add any energy to the system, it's going to start swinging back and forth unless you find some way to actually stop it. It is fed by kinetic energy, so there's the oscillation is going to continue as long as there's energy available. When looking for a first solution to this, there was a gentleman named Sid Knox, and I don't know if people remember that name. Sid had a standard RG, and he really went after the shimmy problem because he had had a number of them. His first attempt was to create a balanced nose wheel, and he was going to do that by adding lead weight to the front of his fork. I think that came from a study where at one point the Air Force had fixed a shimmy with the F-15 and put a weight on their nose wheel to help dampen the shimmy. And, well, we're close enough to an F-15, so why not go ahead and put a weight on there. I think Sid put a pound on it, went out and taxied, had a violent shimmy, threw the lead weight off the airplane, thought it was going to go through the prop, and said, well, maybe that isn't it. So instead, he was able to get a hydraulic damper from a Cessna, which is a Lord-type linear hydraulic damper, and he mounted that onto his RG. It did have some issues because everything had to be lined up just right for it to be able to retract up into the nose, but he was very pleased with the results in damping the shimmy. So I started looking a little bit more at the shimmy, or at the hydraulic dampers. One of the first issues that we'll kind of get to, because I'm going to get on my soapbox here, shimmy is a physical phenomenon, but we're dealing with people. And I have had plenty of people, when I talk this over, tell me that they're never going to have a shimmy. And this was an email or a post that was actually up on the Reflector, the precursor to the VOBA forum. If you'd like to take a minute to read it, it really is kind of a grin. And I've talked to WJ about this, and yeah, he was pretty certain he was never going to have a shimmy. That always happens to the other guy. To be honest, I think most of us are. That's like a lot of things in life. It happens to the other guy until it happens to you. There's no exception. It's just a natural phenomenon. So if you have a castering nose wheel, you have the potential for shimmy. So the first thing to battle or trying to understand this is it's more than an engineering problem. You have to understand, yes, it could happen to you. What we have on there, the Bellville system, Danny started out with it, but I think he got it from Burt Rutan. It's been around for decades. And you know, people are certain Velocity would never sell a kit that has this kind of problem, or why would you sell me this damper? It's just too expensive. You're trying to get money out of me. I'm not trying to get money out of anybody. But also the number of pilots that think that they're so smooth and they will never have this problem. It's really kind of a high number. Like, right on, guys. Good for you. Well, good luck with that. Now, this is the part, if you've never experienced a shimmy, I really, really, really hope you never do. It's violent. You do not want to be in any vehicle when it is shaking as hard as it is. I wouldn't be surprised if the oscillation on our front wheel was 30 or 40 a second, and our front wheel probably weighs 25 pounds with the fork and the wheel and everything, whipping back and forth. It is just awful, and you are certain that the airplane could come apart. The panel blurs on you, and you just know this thing is going to break. It's awful. It's truly kind of event that if it happens to you, you never want to have that happen again. And the whole reason I'd like to give this discussion, we've had some questions come up on the Facebook and even on VOBA on whether the damper or changing to a damper is a good idea. I'm here to tell you I think that it is, because if you haven't had a shimmy, I'd really like to keep it that way for you. Now, you may not take my advice. That's fine. And you may never have a shimmy. That's fantastic. But, well, we'll just go forward and I will present what I have. Now, if you do wind up in a shimmy situation, you can do a couple of things. You can hit the brakes and hit them hard. Thing is, that drives the nose down harder and actually feeds more energy into it. You'll find, and I know this, that if you hit the brakes really hard, it gets even more violent. You can lift the nose. However, if you have the Bellville washers, and they allow you to turn the wheel 360 degrees. If you go look for the first flight video for Brett and Elizabeth, 44 Victor Fox, watch the nose when it touches down. The Belvilles were not tight enough. The wheel skipped and it actually turned 360 degrees, and at one point was pointing 180 degrees in the wrong direction. If it's turned that much and it gets set down, that's enough to whip it and possibly snap the leg off. So it's kind of a crapshoot if you lift the nose where the wheel might stop and where you try to put it back down again. If you decide I'm just lifting the nose, going to hit the power and go around, well, you can do that, but also you don't know where the wheel ended up and you have no way to adjust it. My suggestion would be, if you wind up with a shimmy, to hit the brakes as what you would reasonably do, to try to keep it on the center line, and you've already bled off some energy. If you come back around, you're going to, one, have the wheel, possibly have the wheel in an odd position, and two, you're going to be coming back in at a fresh 80 or 90 knots to have it start all over again. Leave it on the ground and ride it out. None of those are options that I think anybody's going to like, but if you're on the ground doing this, don't make it worse. Don't lift it off and try to put it back down. I think Don Johnson had done that, and his gear snapped the second time he touched the wheel down. Once the shimmy starts, there are only two ways that's going to stop. One, you get enough energy out of the system so that the wheel starts to come back in trail. Or two, the system will destroy itself and there's nothing left to shimmy. These are some pictures that were contributed. On the far left is the taco gusset from Rene Dugas. And you can see that it completely ripped the gusset off of the gear strut. The second one is the interior of the nose wheel, and you can see that it destroyed the casting when he had the shimmy. Another potential Here is Don Johnson. WJ had the same issue. Not the first. I don't know how many this has happened to, but the shimmy's so violent it just takes the leg right off the airplane. For some reason, and I'm going to knock wood here, Velocity, when it throws stuff off of the nose gear or even throws the nose gear off the airplane, very few of those go through the prop. So there's a silver lining for us, guys. The next is another eventuality, and that's the gear fork. That's my airplane. That's my nose wheel. I'm going to tell you a lot more about that. Now, if you do have a shimmy, most shimmy with our setup will settle down and it'll just roll straight once it gets to about 35 knots and down. So if you're at 80, you just got to ride it until you get to 35 and it should straighten out. But it's going to be awful and you really won't know what hit you. It'll be a smack in the face if it happens. Now, what does it take for a shimmy to get started? Your tire out of balance, your tire's out of round, your tire's coming in contact with the gear fork, pebbles, rocks. Your Bellville stack isn't tight enough. You come down and the airplane isn't perfectly on line in the center line. The simple answer is anything that gives energy for lateral movement, and if you just have the Bellville washers, that's a friction system. The energy it takes to move the tire, and that's even what we set it at, we set tension for what is called stiction. And stiction is the force it takes to break that friction and get the wheel moving. Now, because of the way the system is set up, the way it works, there's a higher force to break it out, and then once you start moving the tire, that force is lower until the wheel stops again, and then you got to overcome the stiction. But the turning force, the frictional force while the thing is moving is actually lower. All you need is any event that cocks that thing and starts moving it sideways fast enough to overcome the Bellville washer friction, and it can begin shimmying. No guarantee that it will, but that's all it takes. It needs to just skip. Have any one of these things happen. If you've looked at your gear fork, we think one of the largest issues, slightly underinflated tire, you come down and skip it just a little bit, and if you look at most forks here, there's rubber on the inside of it. Just about everybody's tire at one time or another, or possibly very often, comes in contact with the gear fork. That kind of deformation with a standard tire and wheel is enough to begin a shimmy. And of course, my favorite, and what really happens to me, is Murphy just wants to screw with me. He loves screwing with me, and maybe he thinks it's funny. I've yet to find the humor in it. Now, I hope everybody has had a chance to look at the shimmy video that I posted. If you'll notice, the first one, which was funny, which is at KR2, he comes down and his nose wheel is already cocked. Something must have happened. It might have skipped when he took off, but because it was cocked, that was enough. It was going to whip back to the center. It was going to overcome the frictional forces. He was almost guaranteed to have a shimmy when he touched down, no matter what happened. The second one, I think, was an RV, but could be a Grumman. I don't know. What was interesting there was the shimmy set in instantly when he touched down on it. The one saving grace, and the reason I put that one up, was he must have had a heck of a lot of flaps in. He wasn't moving very fast. So the shimmy came on, but it also came off very quickly as soon as the energy came out of the system. The one that everybody laughs at is that poor Berkut. I put that one in there because I wanted you to see how quickly this can happen. He skipped it twice, and then the entire strut just came off the airplane. And the last one I put up there was that poor Cessna. If you watch it towards the end, you can see he's applying some heavy braking. And as he brakes, the shimmy gets so violent that the tire is so out of round, I'm certain that the thing almost jumped the rim while it was doing that. The part that's kind of a little bit ironic there is that Cessna has a hydraulic damper on it. It needs minimal service, but it does need service. It does not work if you don't keep oil in it, if you don't keep the seals in good condition. This is our Bellville washer setup. It has a lot going for it. As far as Burt Rutan goes, it's almost the perfect solution. It's very simple, it's very cheap, it's very light. It does do the job. It's used on Cirrus and RVs and Long Easies. It's been around forever. If you can believe this, NACA actually wrote papers and has the data on how much force you need to have based on your touchdown speed, the weight of your wheel, the weight of your fork, the weight of the airplane. If you plug in all of the numbers, NACA will spit back, this is how much breakout force you need to put into the system. My friend John Tweet, he's an engineer, his brother's an engineer, his brother-in-law is an engineer. They're all aeronautical engineers, and they took up the challenge and actually plugged in all of the numbers for a Velocity fixed gear nose gear. The NACA formula shows that we should have actually about a 40-pound breakout force on the rear of the wheel to guarantee we'll never have a shimmy. 40 pounds would also mean you probably couldn't turn the aircraft, but hey, it would guarantee you wouldn't have a shimmy. So it's not really practical to run it that way. The thing works all the time, which means the Bellvilles are there constantly. You don't have to remember to engage something. You don't have to turn it on or turn it off. It is intolerant of adjustment error, so if you leave it a little too loose, it can be a problem. And it also, I think the way ours works, if you're turning left, that frictional force is actually kind of working to loosen the nut on us. That's why Velocity preaches that you really, really, really need to check that before every takeoff. Because if it gets too loose on you, you are really, really at an increased chance for shimmy. I have seen people set the force and drill it and put a cotter pin in their nut, but man, that's really tricky because sometimes it's not even a quarter of a face between too much and not enough force for the friction on the Bellvilles. The Bellvilles are not a shimmy damper. They're a shimmy preventer. It's keeping shimmy away by not allowing lateral force. I just did a little back of a napkin. Say you had a Velocity weighed 2,500 pounds, it's touching down at 80 miles an hour. The wheel is 9.5 inches in trail behind the pivot point, and the shimmy starts in and the thing starts going back and forth 15 degrees off of center left and right. The videos show it's actually probably a worse angle than that. We calculated just very roughly, when it's at the furthest on the outside, there's about 1,900 foot-pounds of torque pushing that thing back towards the middle. 30 pounds of resistance from the Bellville washers aren't even a consideration at that point. It's not going to stop it. So it's a shimmy preventer. If it stops it from ever happening, great. If it ever starts, it's useless. Side effects, I guess, of the Bellville washers. The friction is there all the time, which means it makes it a little bit of a hassle when you're taxiing the airplane with these. You can look like a drunken pilot shifting back and forth, and trying to get it to stop exactly in the center to track just the way you want to can be a bit of a challenge. I had a talk with John Abraham about this, and he said he'd seen people who absolutely positively didn't want to have a shimmy, so they were really, really cranking down and putting 30+ pounds of breakout force on the nose wheel, and they were creating problems. It was damaging the gussets on the nose strut, and also he had one of the owners had damaged one of the bushings that was in the keel. When you make that tighter to turn, that energy has to go somewhere, and it's being transferred up into the rest of the airframe. So just tightening the nut and taking it as it's going to be hard to taxi, that's not a good answer either. If you do take off, and say you were in a very heavy crosswind, and the wheel did not line up with the center line of the aircraft, aerodynamic forces will never be able to push it back into the center. That is an issue. It's always been there. If you have a wheel pant on there, it works like even more of a rudder. For a retractable gear, not so much of an issue, because when it gets pulled up, the guides will straighten it when it goes into the nose. Scott Swing and I just had a discussion on this, and I think he has been telling some fixed gear people that they shouldn't install the damper, because he tried to take off once with a 20-plus knot direct crosswind, and when he took off, the wheel was, of course, tracking with the direction of the airplane and was canted when he lifted off. I don't know how that has to do with the damper, because that's locked in place by the Bellville washers. I don't know what that has to do with any damping solution. Maybe 20 knots as a takeoff. I don't know that I would attempt taking off with a 20-knot direct crosswind. That's just my own issue. He would really like to come up with a damper that has ports on either side, and then he could use it as a steering mechanism. I asked him when he's going to do that, and he said, well, he's got a really long list and he's wanted to do it for years, so we don't know if or when he's going to do it. But with the Bellville washers, if you take off and the thing's off center, it's never going to center back up in flight. There is another solution that's an even more robust, that's all kind of along the same lines as the Bellevilles, and that's the Mishler nose wheel lock. I don't know if everyone has seen this. Ken Mishler came up with it. It's a pin is inside that housing on the back of the strut, and there's a cable that goes up into the cabin, and you can push that pin down into the plate underneath, and it essentially locks the nose wheel to the strut. You pull onto the runway, you push the pin down in, and the nose wheel can't be steered. It can't move. There's no lateral movement, period. It's very effective at stopping shimmy, as long as you remember to put the pin in. And then you need to leave it in throughout the whole flight. You land with it like that. The airplane is steerable with it locked up. You're kind of dragging the tire. Ken even said it was possible to steer the airplane off the runway with it, the pin engaged, but it is not easy, and you know you're kind of abusing the nose gear doing it. Ken is not in good health, and these are not available for purchase right now. I think Velocity would like to have them available, but I don't know if they will ever get the rights to it. And it is also available, or when it was available, it was installed on both fixed and retract airplanes. Looking at a production aircraft solution with hydraulic damper. Hydraulic dampers are on just about everything, all the way up from the largest airliners have hydraulic dampers on them. Cessna, Piper, Beech, Mooney, they all have hydraulic dampers on the nose. A hydraulic damper is a wonderful solution. It works by having a piston that's perforated or has a passageway, and movement forces hydraulic fluid from one side to the other. It always works. You never have to turn it off. You don't turn it off. The resistance climbs as the motion does. So the harder you hit it, the more it's going to resist. It's kind of the opposite of the Bellville washer solution. It is both a shimmy preventer and a damper. It requires minimal maintenance. You do have to inspect it. You do have to make sure that the seals are good and it's filled with hydraulic fluid. And mechanically it's attached the way it should be, but once you do that, the thing just works. Nomenclature, it is a shimmy damper. A damper dampens. So it is a damper, not a dampener. Scott's Performance even has a whole page on this. Please just call it a shimmy damper, not a shimmy dampener. as for Scott's performance, the idea for using this type of damper actually came from a conversation with Bill Mulrooney. And I remember being in Camp Scholler and talking this over with him, and he said that he had looked at these for his motorcycle and thought that they were an ideal solution. They're about the size of a hockey puck. The whole thing weighs less than a pound. He doesn't know how you would go about mounting it, where you would put it, but he pointed me in that direction, and I researched several of them. I liked Scott's, and it's Scott's, not possessive. It's just Scott's performance. I liked them because they were made here in the States. They had a high speed and a low speed setting. They had a sterling reputation in the motorcycle industry. Everybody seemed to love them, and I gave them a call and asked them, hey, I'd like to install one of these on my vehicle. And I didn't want to call it an airplane. And I was speaking with a guy named James McClellan, and he was their lead engineer. And he was like, well, we do all kinds of stuff with the damper. If you've ever watched a football game and seen how the camera flies over the field, nice and smooth, he says that smoothness is provided by Scott's Performance dampers. So their dampers are used in many different applications. And I wanted to know if this would work for us. And he kept hammering, what is this for? What is it for? And I finally told him, all right, it's for an airplane. He went, sweet, that's awesome. Can I see a picture? So I sent him a picture of a Velocity. He said, oh, this is so cool. Yeah, we'll work with you. And so James first wanted all of the numbers. What does the airplane weigh? How big is the nose wheel? How much does it turn? We had to send him a lot of data, and it took him about a week. And then he came back and said, we've run all the numbers, and it looks like this is going to be a really great solution. It's right in the middle of our sweet spot. For performance, this damper should really work well for you. And we will help you to develop the installation for it. I thought that was amazing. So I put James in touch with Scott Swing as well, and kind of the three of us just had started down the road, let's see if we can't get one of these installed. Scott seemed to be pretty excited about it because I think he really wanted a solution. How does it work? Well, this is the inside guts of it. The inside has a pie-shaped area. There's hydraulic fluid on either side of that wing. The center shaft is what sticks out on the top that we attach to. And all of the magic is actually in the cap. You can see these little bitty holes on the plate on the left. That's where the hydraulic fluid gets pushed from side to side. They won't let you in there, and that's all proprietary how it works. But that's essentially all it's doing. It has a 95-degree total sweep inside. Scott had originally thought, you know, well, we've got this stubby little post on it with these shear pins. And we thought, well, if we had the right bushing, we could engage something sticking out of the bottom of the strut. So I had access to a mill. I made a bushing, and it fit precisely over the top of that. But I didn't have the bracket on the front, wasn't sure how to get it lined up. Was talking it over with Scott, and Scott just got a little frustrated and said, just send me the darn thing. Give it to me. I'll get it taken care of. So it all wound up in a box and sent down to Scott Swing, and Scott installed it on the trainer. And this was actually the fork and the damper that I had sent him that wound up on the trainer. And the people at Scott's, James thought it was pretty good. Now, you'll notice that there is a shear pin going through that post. That's actually a liability for us. We never want the thing to become disengaged. I had asked James about that, and he said that they had to install that. The original dampers never had one of those, and people were going out and hitting something like a big rock really hard, and the damper is so strong it wouldn't break, and they were bending the forks on the motorcycle. So the customer base said, you need to put a shear pin in there because I'd rather have the damper shear off than damage the motorcycle. Well, we're kind of in the other case. We don't want the airplane to get damaged, so don't let the thing shear, but it was what it was. We didn't think it was going to be a problem. Scott installed it on a trainer, and Scott and John started using it. The staff was unfamiliar, and they're very used to picking the nose of the airplane up and kicking the nose wheel around 180 degrees. They didn't notice that it had a damper on there, and so they kept kicking the wheel against the damper, and a couple of times they damaged things and had to go back to the shop to fix them. But they were able to find damper settings that worked. Largely, they had to find out how much the Bellville washers had to be used, because you need both the Bellville washers and the damper on there. And then they trained 10 new pilots in the trainer using the Scott's Performance damper. This was back, I think, around 2011 when they started doing this. They slowly were backing off the Bellevilles, and they said eventually they trained one pilot with the Bellevilles just barely engaged. Never had a shimmy with it. They tried to make it shimmy, and they couldn't. The thing is, they never tested it with a wheel pant on the trainer. The wheel pant adds mass after the pivot point and can tend to increase the possibility of shimmy. Now they sent me back the fork and the damper, and Scott went about coming up with an installation for the retractable gear Velocity. It went on my airplane just as a slide-on kind of thing. I needed to put that bushing in the bottom of it, but it was there. First flight, flew it all summer that way. First time I put a wheel pan on it and touched down, that damn shear pin sheared right away. It's too soft. And it was just a violent ride. You can see the skid marks heading down the runway. It was very ugly. I was scared, to be honest, when that happened. After the event, I talked it over with Steve Zollinger and James at Scott's, and they said, yeah, the pin is too soft. We recommend you put in a much harder pin. At this time, Jorge Bujanda had also agreed to experiment, and he had one installed on his airplane. He had the shear pin go on his. I'm trying to dig up the video on it. Jorge said he'll find it for me. When he touched down and the pin went, there's actually a video of his nose lifting, and I think the front wheel spun around, did 3 complete 360s before it touched down again. He has in-cockpit video, too. It was horrible. We found a new pin on McMaster Carr. It's essentially drill stock. It's hardened steel, much harder. We were able to essentially cut it to length and slide it in place. Now I'm going to kind of cue up some sad trombone music, and because I got a sad long story coming, but this is part of what it takes to develop something like this for our airplane. After this, the damper went back to Scott's Performance. They tore it apart, wanted to see if there's any internal damage. There wasn't. They said you just need a new pin, but everything internally was still fine. The stop for the paw in the back was bent badly. I made a larger one with 4 holes instead of 2. Told Scott about it, and I think the RG one wound up being wider then. And we replaced it with a hardened pin. Well, everything was fine. Flew it all summer. Put the wheel pants on it. It flew just beautifully. No sign of shimmy. Put the interior in it. I'm telling you, life was good. After the initial pin had sheared and I had the shimmy, I inspected the fork, the strut, looked up inside the keel with a scope. Everything seemed to be fine. Flew it to Oshkosh. If you look just off my left wing, that's Richard Cano's Velocity. He went on to win the Silver Lindy that year. I was just tickled. Everything was fine. I bought my Sky Radar unit at Oshkosh that year and brought it back home, and Carlos and I installed it. The very next day I got back from Oshkosh. Now, this is one of those things where, very typical for aviation, A causes B, and then B causes C, and if A had never happened, B or C wouldn't have happened, but it did. That's what happened when I made the first landing after we installed the Sky Radar. Look at the nose wheel. It's not good. There's what happened. That's the gear fork, and it's split into 3 separate pieces. I had my lovely bride go to Home Depot. She picked up a furniture dolly. We put a piece of lumber on it and limped my airplane back into the hangar. Now, I'm going to talk a little bit about the gear fork here, a lot. First, you should know that we do not have these failing all over the place. Your gear fork is probably fine. However, we did a deep dive on the fork. How is it we didn't know that this was even a possibility that a gear fork could fail? I found out that the company that makes the forks is called Southern Casting Solutions. They're also located in Florida, just outside Orlando. Adam Kallmeyer is the owner, and we sent him the parts and asked him if he would answer questions. John Tweet, who's a Velocity builder, my friend John, happened to be in Orlando for a vacation and went to the foundry and actually looked at the parts, looked at the whole operation, and talked to Adam. He was not that familiar with the Velocity gear fork as he had just acquired it, but he had years and years of experience in the industry. And he said other than it being broken, it doesn't look abnormal. He said the porosity was normal for the material and the process. In his estimation, this casting was no stronger or weaker than any other. So he didn't see this one as being any different from the rest that would be out in the field. He did note that it broke through the thickest section of the fork. He said it was where he would have expected it to break. He explained the casting is strongest with the uniform thickness throughout the part. In thicker regions, it will cool at different rates and create a variation in strength. It's kind of counterintuitive, but as he explained it, it made sense. Our forks are made from an aluminum alloy casting, is conventional methods. The foundry suggested the alloy is likely 535.0-F, which it turned out to be. John looked up the numbers and said that's actually probably the very best alloy for the application. So it was well chosen and well made. The fork is cast such that it can be machined into either a fixed gear or a retract gear version. So it's the same fork either way. The kingpin boss just goes through one way for fixed and the other for retract. Cast aluminum was chosen as a compromise between strength and cost. Cast aluminum parts suffer reduced strength properties and the higher occurrences of internal flaws. The forks are not heat treated after casting or final machining. Heat treating would increase strength and would also increase the cost. The existing fork has had a number of incidents, and I did not know this, talking with John Abraham at the factory, but multiple forks have failed catastrophically. Others have had visible cracks in the aluminum boss adjacent to the bronze bushing and were preemptively replaced before it did break. It's unclear whether the fork failures are due to low cycle fatigue and crack growth or simply due to overloading. In a discussion with the foundry, it was suggested that due to the way the fork is cast, the large boss area with the core removal, that the thicker areas would solidify more slowly while the thinner side edges of the fork would solidify more quickly. The foundry thinks these uneven cooling rates are likely residual stresses in the critical area of the fork shoulder. We'd taken this fork and digitized it, put it in a CAD model, plugged in all of the parameters we got from Scott Swing of what's the max weight, typical weight, what is the landing speed, all of those numbers, and put in the alloy and ran a finite element analysis on it. Some surprising things came out of the analysis. If you look here at the blue fork, the stresses are all concentrated right here. And that's where it was projected that it would break, and that's exactly where it did break. The other parts that we did not know were because of the alloy that was chosen and the way that this actually works, you can get deformation internally in the part, which means the inside can work hardened without showing cracks on the outside surface. There's no test you can run aside of ultrasound or x-ray that would tell you that the fork could be compromised internally. You can inspect the wheel, the tire, the strut, and airframe. You can do all of that for damage, but there is no simple test after you have had a violent shimmy to tell you if your fork has been compromised. My recommendation is, if you've had a violent shimmy with your airplane, I'd replace the fork. There are guys who've had violent shimmies that are flying on the same fork, and they have not had problems. That's about all I can say about that. It doesn't just happen to fixed gears. This fork was from John Youngblood's Lindy Award-winning Velocity XL-RG, coming back from Sun and Fun. Yeah, it split in half. The wheel, he thought, was going to go through the prop. It did not. He said he got lucky on that. But yeah, he wound up grinding down the runway in Missouri on the broken end of the strut. It doesn't matter what airplane it is, what model it is. It's a matter of what the fork's made of and how it's used. Getting on to what we did about the shimmy. Had I replaced the fork, I probably never would have had the problem and could have gone on with the original setup. And probably, knowing what I do now, probably could and should. But instead, we created a square post damper with the help of Scott's Performance and got rid of the shear pin. The square post goes into the square bushing. There it is, all set up. They assembled it, they tested it, and I installed it. There it is on my airplane. Next, we took the data that we had from the finite element analysis, came up with an improved gear fork, and we had it milled out of solid 7075. 7075 has aluminum alloy with some tin in it. It also goes through a heat curing and stretching process. It's stronger than some steels, yet is light like aluminum. Absolutely a wonder metal. The downside of it is it's expensive. Whoever's asking how you buy a billet fork, well, we're still working on it. Randy is the guy in the picture, top middle. He's the machinist. He's already trying to machine 3 prototypes. His shop has been exceptionally busy trying to make parts for race cars, which is what they normally do. I suspect he might have some downtime here, and we might get prototypes of the RG fork. As far as the fixed gear fork, we did one run. I think we had 15 people sign up. All 15 sold. I will tell you, I turned all of this information over to the Velocity factory. They got all of the CAD files. I gave them all of the tooling. They had contacts for Randy DeHaan here who can machine them. Riley, Brian, and Scott Swing are complete advocates and would like to have all of the forks sold by Velocity be billet. Dwayne does not want to do that. He thinks it's too expensive and has said no. So there it is. I don't know if you can buy the CAD model off of me. It actually belongs to John Tweet. We could ask him. So there's the billet fork. I really wish Velocity had just the billet fork, because you don't hear of the problems often until it happens, and then it's very disheartening when you call the factory and find out, oh, you're not the first one that's had that problem. We already know the fix. Okay. No, the SE fork is smaller than the XL fork, but we do have one designed for it. With the new fork, we have a much greater clearance. You probably saw that there was a Behringer tire on there. We chose that Behringer tire because it was a little bit narrower, and I think we had over 5/8 inch clearance between the wall of the tire and the fork. And in all the years I've been running that, I've never seen any rubber on the fork, so it does not seem to slap around in there, and that's another way to keep shimmy away. Here is the RG fork, and this is courtesy of Rene Dugas. Rene unfortunately suffered a rather violent shimmy. You saw that it broke both the wheel and his strut. In the upper left, you can see the mount that Scott Swing came up for the RG damper, and he used that largely off, designed that largely off of how they mount them on motorcycles. That little arm is underneath the damper, and it engages a pin which is attached to the strut. I think it's ingenious. It allows you to turn the wheel one way and it can go 180 degrees. You just have to turn it back the same way so it re-engages the pin when it comes back around. I think it's brilliant. For the fixed gear, after we went through all the trouble for the square post mount and talking with Scott, this is now what he has for a fixed gear mount. And it uses the same parts as the retractable gear, mounts largely the same way. You can see there's a slight upward cant that he put on the bracket to lift the damper away from the tire, but other than that, it's the same install as the retract. It's clean, it's simple, it's the same parts. I think that's what you would get right now if you ordered it from the factory. Operation. I've been around the Velocity community now for over 20 years. I do recall that on the Reflector, which was our internet forum at the time, shimmy was a fairly common occurrence. There were always a couple happening every year, some very violently. I was one of those people who thought it was always going to be somebody else's problem and I wouldn't have that problem until I dug into it and went, oh. It's not a perfect solution. There have been some people who have had shimmies even with the damper on there. I believe that shimmy is more between the tire and the leg, but it's also very destructive, and I think it would possibly even tear the damper apart. There's a lot of energy there. So it's not perfect, but it's way, way, way better than what we had before. The factory's been installing these as standard equipment since 2013. Every airplane that rolls out of there now has one on. To install it requires a little bit of machining. Originally, Velocity wanted you to send them your fork and strut, and they would do the install for you. Now I think Scott has things set up with templates, and he can just send you the kit, and you can do the mount yourself. It takes about 2-3 hours to completely install it. If you want, you can send him your fork and he will install it for you for 95 bucks. He sells the kit right now for around $600. You still need to have the Bellville washers on there, but you can really reduce the amount of tension on them. Mine is right around in the 10 to 15 pounds of breakout force. It's just enough to keep the airplane tracking straight. Oh man, I love the way it taxis. Sometimes I think having the damper on there, the bigger upgrade was how it handles on the ground over not having any shimmy problems. It's like butter. With both of the new installs from the factory, the wheel can be turned 180 degrees for pushback. John, you measure the breakout force. Some people do it with a fish scale at the back of the tire. And it's how much force you need to push on the tire to make it break out and start moving. The factory, I think, has it, 15 to 20 pounds? But I've seen recommendations in the 20 to 25 pound range as well. The stiffer it is, the less likely you are to have a shimmy, but also the worse it handles on the ground. At your condition inspection, if you have the hydraulic damper, this is my recommendation. This is what I do. I loosen the nut. Actually, I wind up taking the whole thing apart, cleaning the Bellvilles up, and putting on a new coat of light grease. But just checking the damper, I loosen the nut until it's only the damping action that I feel, and then I move the wheel back and forth. There shouldn't be any slop or clunking around with it. There's very little room for slop in the whole system. You shouldn't see any hydraulic fluid anywhere. It's a grayish green goop. If you saw a drop of that, you may need to take it in, and Scott's will do an overhaul on it for you. Check that all of the engagement hardware is nice and tight. The little bracket that gets bolted onto the strut has to be very tight on there because that's what the damper is working against. And then grab your strut. Make sure it does not slop back and forth side to side. Then after that, I highly recommend you balance your tire. That's always a nice thing. It doesn't shake when you take off and the thing spins down. And check the pressure in it. That's, I think, about it for the presentation I have. Let me see, let me scroll through some of the questions here. Yeah, I know you guys want a billet fork. I want you to have a billet fork. Okay. Yeah, Mike, I know Scott recommends the damper for the RGs and a locking pin for the fixed gear. Now, I have the hydraulic damper on my fixed gear and absolutely love it. I would do it if only for the ground handling, but also once the system was in place and tested and we finally got it right, I've never had any shimmy issues with it. The reason Scott doesn't want that on a fixed gear is because if you put a wheel pan on there, and like I said, he tried to take off in a heavy crosswind, with the lower friction on the Bellville washers, I think the wheel tracked more and wound up getting cocked off to the side. 20 knot direct crosswind is probably not something that I do. I've never done that before, and I've never had the problem that he has described. If you were that concerned about it, there's no reason you couldn't, if you wanted to, run the Bellville washers up as high as you wanted, run belt suspenders and Velcro if you wanted to keep your pants up, and then it will perform just the same. The issue that I think Scott is saying there is more to do with the Bellville washers than with the damper. That's, your mileage may vary. I prefer the damper, but it's your airplane. What kind of nose wheel fork attachment mechanism does other home-built airplanes and even the Cirrus? I'm not an expert in those. I think the RV is very close to what we have, and I know the Long Easy is. I've never really looked that closely at what a Cirrus has. If somebody else knows, maybe they could fill us in. You're right, Steve Campbell said that the RVs do not have the same type of fork. I think those are slab sides and they're welded. But I have had friends who have RVs look at our system, and I could see some gears going on in their head. I think they would possibly like to have a damper on theirs. It's their call. I don't think they have as many shimmy problems, but I'm not an RV driver, so I don't know. Yeah, Renee, talking about the Behringer wheel is, yeah, it's better bearings. It's just an all-around better piece of hardware. I love it. I think it's beautiful. All right. Does anybody else have a question that I might answer that we didn't get around to? Happy to answer anything we can.
Man, that was quick.
Andy, I'm wondering if I'm having a lot of trouble trying to turn the aircraft when I'm at either at standstill or very slow speed. Is that an adjustment on the damper?
You're having trouble turning the airplane at slow speed?
Yeah, I mean, from a stop, if my wheel happens to be pointed off the runway sort of thing, and I give some power to get started, man, I got to go 5-10 feet towards the edge of the runway before the thing will start to come back to the center line on you know, braking action. So is there something?
Yeah, you may be able to loosen the Bellville washers a little bit. I have found when adding high power like that, the nose won't turn, and Renee may be able to help more with this, but the nose doesn't turn unless the aircraft is moving forward. So I wind up pumping the brake hard on the side I want it to go to, rather than just trying to push on it. So I let it go forward and then come off. So it's a pumping motion, and I can usually get it to start turning within about a foot or two of movement.
Okay, I'll give that a try.
Renee, do you have anything on turning the airplane?
I agree. I think if you pump it with sometime 1,200 RPM, something like that, it'll usually start to turn. But I agree also that Bellville washer tension is going to be a big part of that. If you can loosen it and experiment with it a little bit, that'll help. Increased air pressure in the tire.
What do you recommend?
I run about 35.
Thank you.
Anyone else with a question?
This might be a good time for me to, since we talked about tire pressure, is to remind people, don't let it get low. It drops your nose and can increase your takeoff roll very dramatically.
What do you put in the mains?
I run 55.
I run 55. I
Okay.
run 55 and 45, Bob.
Okay, I think I've got 45 in my mains.
Yeah, I've
Not
got
sure.
55 in the mains and 45 in my nose.
So somewhere between 35 and 45. Okay.
Now I'm running a retract, so my breakout tension may be quite different than a fixed gear. I don't know. I'm running about 7 pounds of breakout on mine on a retract XL.
Okay, mine was set by the book at 15 pounds. So.
Oh, you'll find it taxis much better with a damper with that decreased. It's as Andy said, it's butter.
Okay, thank you.
Well then, thank you all for attending. I appreciate your time. Everyone stay safe, and until we meet again, have a good evening.
Thanks, Andy.
Yep. Thanks, Andy. That was very good.
My pleasure. Thank you.